Well, hello, my wonderful physics students. Today in this video, we will talk about how to deal with things on an inclined plane and how to find the net force, the acceleration, and sulfur forces on things on an inclined plane. So let's get started. So we have a box here. We have a box that's right here, and it's on a flat surface, and my question for you is, how does the normal force, or is the normal force equal to the weight? I hope you said yes. The weight in this case is down, weight by the earth on the box, and the normal force is straight up and the box is just sitting there, so they're equal and opposite by Newton's second law, not by the third law, by the ground on the box. Okay, so now we're going to tilt the box. Is the normal force equal to the weight in this example? You're right. The answer is no. If we draw a free body diagram, we have the weight going down, and the normal is always perpendicular to the surface. The normal is always perpendicular. So here's the surface right here. So the normal would be perpendicular to the surface. So since the surface is at an angle, the normal is at an angle, the box moves down at a constant velocity. The only way for that to happen is if there's something opposing the weight, the component of the weight going down the incline. And that in this case would be friction. Whenever we have things on an incline or at an angle, we have to change our axes so that they fit the incline of what we're talking about. So in this case, if we put the axes right here, then try to draw as best I can. So this would be our new y-axis and our new x-axis. And as you can see, for my messy drawing right here, the only thing that's not on the axes is our weight. Also, our acceleration is all in our new x direction. So we don't have a component of the acceleration in the y direction and a component in the x direction. It's all just in one direction, which is very helpful to solve these kind of problems. Oh, this should be theta. So this is theta there, and that's theta over here. So when we get the components of the weight, we could ignore the full weight. When the acceleration is equal to 0, your ups, in this case the normal, is going to equal the downs, but in this case is the wy, and your lefts, the friction, is equal to your rights, the weight. And in this case, the weight is greater than the normal because the normal is equal to a component of the weight. Okay, so we saw this problem in class, but I'm going to go over it quickly in the video with you guys. A 70 kilogram skier skis down a slope that is angled at 37 degrees with respect to the horizontal. The coefficient of kinetic friction between the skis and the snow is 0.1. What is the skier's acceleration? So if we write down what we're given this, and this should say mu right here, not m, okay. And we're given that the acceleration is down the incline. Figure that one out. We draw a free body diagram. We have the weight, the normal perpendicular to the incline, and the friction going up. There should be friction right here. I don't know why this was screwing up, so sorry. Friction. The weight is 700 newtons. Use 10 for gravity. We change our axes. And so when we do that, we have to find our x and y components. Now we're going to take a small aside to figure out which angle is 37 degrees. So we have a board and we drive a nail through it and add a plumb bob. As we increase the angle of the board, as we increase this angle right here, this angle also increases. So if we change our axes, the plumb bob represents the weight, and so you could tell where our angles would be for our free body diagram. So our theta is right there in the 37 degrees. You could use your sines, cosines, and tangents to solve for Wx and Wy. And then when we do that, we know the normal of the skier, so the acceleration in the y direction is 0, so Wy is equal to the normal. Friction is equal to mu n. So since mu is 0.1 and the normal is 560 newtons, mu n is 56 newtons. And so then we can do the F net in the x direction, and the acceleration's down the incline. So since the acceleration's down the incline, we go with what forces are going down the incline, which is for Wx, 420, minus the forces going against this, up the incline, which is friction, 56. So 420 minus 56 equals ma. You solve for it and you get 5.2 meters per second equals the acceleration. All right, thank you very much. Bye-bye.